Welcome back to another tutorial in the Metroid series. Today we're going to add the idle animation as well as a run animation, and to make sure that the character is flipping, and we're going to do this all in C#, and also we're setting up the animator within Unity. By the end of the tutorial you will be able to set up your player and also the rigid body, understand the collisions 2D, understand the rigid body 2D and the different settings, set up a running and idle animation, create C# code for the movement, interact with the animator by codes to initiate the right animation. So let's continue where we left off in the last video, which was that I completed an initial part of the map. And today we're going to add the player. And within the Warped Caves assets, there is the artwork, there are some sprites, and there's players. And for the player, there are a lot of different animations. And today we will want to add the idle and the run animation. So let's start with the idle. And what I want to do, or what we're going to start with, is select all these files. So you can see this is the idle animation there. Let's zoom it here a little bit, and let's just drag it in like this. And you can see here that it wants to make a new animation, because we're just going to make the animation by just pasting those 4 pixels in, and that we start off with the idle animation. What I want to do is here perhaps make a new folder, and let's call it player animations. So we have light animations, player animations, and just call this idle. Now the good thing of dragging let's say the player in is that it already adds some components like the animator, the sprite render, whereas if you would just add a player here, you have to add all those components one by one. Let's change the name, because now it just took the player idle1 name, and let's just call this player. And what's important is that we also tag this as the player, and the layer. And as I mentioned in the last tutorial, there is a layer, which is the functional layer, and there's the sorting layer. And I want to have a layer, which is, let's say, the player layer, because the player will interact with different things later. Press the player again, and let's just put here player. So the layer is player. What I can do is that the player layer can ignore certain things if I wanted to ignore certain collisions. And then the sorting layer is the player, and you can see here the player is very small. Let's make it a little bit bigger. Let's put here just 5 perhaps, or 6, however you like. I'm just going to put it on the player on 0, which is fine. And what I want to add, of course, to a player are a couple of components. And the first component is a rigid body, because a rigid body 2D. And what we're going to do is the body type is dynamic. So it can interact with statics and of course collisions and everything. And you have a gravity, currently at 1. You can play with this later. You can also make it higher. Usually if you put the gravity a little bit higher, your controls get a little bit more snappy. Otherwise you have this floaty feel. So let's perhaps check this later. Collision detection would always make it continuous for the player, so it continuously updates the collision. And currently it doesn't have a collider yet, so we'll add that in a bit. And what's also important is that you go to constraints and freeze the rotation on the z-axis. If you don't do this, you will see that the character will fall over and tilt. So let's freeze it on the z-axis. Material is also quite important to add a material. You will see this later, especially once you start jumping, and I'm going to do that shortly. And I already made here a player material, and let me just delete this. So I made a material folder. What I'm going to do is to create, and then I'm going to create a physics material. And it should be a 2D physics material 2D. Yes, and let's call this player. And you can see here the friction and bounciness, and I like to put this all on 0 as a general. And then we can just go here to the material and select player. So, and now it will slide off against walls and stuff because it has no friction. Good, that's the rigid body. Let's then add let's add a capsule collider 2D. And the capsule collider You can also put here a physics material if you like to, but usually it will just get of the rigid body material. Vertical is alright. Let's make sure that we put it on the character like this, perhaps. And this is a little bit the question. Let's put it where the legs are. And if we now press play, so we have the capsule collider and the animator. And the animator, you will see here the animator. By the way, you can go to window. If you haven't opened this yet, in the last tutorial we made some lights. So there's the animation. And always open the animation pane and the animator tab, these two tabs. And now we have standard, the idle. So let's just have a look. And as you can see, now the character is there with the idle animation. The idle animation is quite fast. And to change the speed of, let's say, the idle animation, you can just go here in the animator. And perhaps you can just change here the speed to 0.5. Great. And while we're at it, let's also add, let's say, a new animation. And let's call it running. And what we do here, we go to the run and we drag in these sprites. And you can see it's running very fast. And also there in the animator again, we can perhaps just make it a little bit slower, 6. And now we have to set up the run in code. To do this, let's first make a folder where we're going to, let's say, make all the different scripts in the assets. Let's make a folder, let's call it scripts. And what we can do, we can actually just go to the player and add a component, and we can just write here a new script. And what should the script name be? Let's call it player controller. And perhaps with scripts it's always better to not make any space. That's just my opinion. Usually it should work, but we just make here the script and the player controller. Let's drag it into scripts as well. And then let's open it up and start coding. And before we start coding, I would just recommend you, if you're totally new to this, is to add the extension. And you have some extensions, roaming extensions, and there's the Visual Studios 2019 tools for Unity. And this will add, let's say, all the codes for Unity. So if I write rigid, then it already comes up with rigid body and these kind of things, which are, let's say, Unity standard codes. And this you will need anyway. All right, so let's start coding. The first thing we want to do is a public float. And a public float can always be accessed from the inspector. You can also make your comments, let's say like this, accessible by inspector, just to keep track for yourself. And let's call this the movement speed. And we can already give a, let's say, a round number, and let's do it 5 frames. And let's close it. What we also can do is make here private floats, and we will need one later. And let's call this private float, and let's call this input direction. And let's close it. And what's nice here, this is not accessible by inspector, so you cannot change it, let's say from Unity, only in the code. And other things what we want to do here are to add states or get states. You can add like Boolean states, but we will do this later. And you can also get components from Unity so the code can interact with it. So what you want to do is, or again, do a private and then do rigid body 2D. And we can call this, give this rigid body a name, and then we can, in the code, reference to that, and let's call it RB. And the same we want to do for the animator, which is also then a private animator type, animator, yes, and we can call it also animator if we want, and close it. And at the start of the game, so the first frame, we want to check and get these, let's say, these functions, and we do that by calling them. RB is get component, and we get then here the rigid body 2D. We have to close it like this, the line. And what we also do is then the animator is get component. And we call then here the animator type and close it. Let's now make the code for walking or running. To do this, we first want to have a code which checks for the input, and we're going to make a private void, and let's call it check input. And the code should be then input direction, and input direction is the, let's say, the private float which I made earlier, and the input direction is input, which is a, let's say, a unity topic, and then get axis, and we want to have the raw figure here from the horizontal action. And you might wonder, what is this? And I can shortly show you. Whoops, now assembles. If you go here to edit and you go to project settings in your input manager, there are already some preset inputs, and the horizontal corresponds with left, right, and A and D. And there is already a certain sensitivity and gravity. You can change these settings here, but in code you can already get then the input from left and right. And of course, let's not forget to close this line of code. And now we should apply movement, and for that we're going to make another private void, and let's call this apply movement, because we want to make different movements in different directions. Whoops. And the code for this is then rb velocity. rb.velocity is new factor 2. And now we play with the, let's say, the float which we made earlier, movement speed times input direction, which we also made. And the y-axis should be just the rb.velocity dot y, so nothing will change here, and then we close it. So there we have it. And of course, if we now go into the game and start, it won't work because we want to do this every frame or make an update. So what we want to check here in the update is, of course, always the input, or let's say not the input, this is check input there. And we want to add a void, normal void, fixed update. Yes, and in the fixed update, we want to apply movement. And why do we put this in the fixed update? Because the fixed update always does it at the same time, and the update checks every frame. So if the frame rate changes in your game, then also your movement will change accordingly, and this is not what we want. So let's have a look if this works. So let's close here the project settings. Let's zoom a little bit. What's important, of course, currently the camera is probably not fixed to the player yet, but let's have a look. So as you can see, very good. You can now, with your arrow keys or the A and D, already move, and you can see that the character will just be in his idle state. Now, to let the camera follow, let's shortly fix this. And what we want to do here is go to the Cinemachine, which we also installed in the first tutorial, and create a virtual camera. And let's just call this the player camera. And what we should do is perhaps create an empty, reset this, and call this just cameras, because we might make more in the future. There's always the main camera, and Cinemachine has, let's say, the main camera now has a Cinemachine brain. I just got it because I added a virtual camera. And within the player camera, I can set here some settings. And what I want to do is have a follow of the player. And now, if I'm going to move, the camera will follow the player around. And what I want to do is the binding mode, lock to target with world up. I want to just have it in world space. Let's try this now shortly. And as you can see, the camera is following the character quite smoothly. And if you go no slopes, you somehow jump a little bit up. And that's what I meant with perhaps we want to play a little bit with the gravity of the player and make it perhaps 2, a little bit higher. And that way you are sticking more to the ground and make it a little bit more snappy. So you also saw that the running animation, of course, did not work. So let's also add this to our code. And to connect the animator, we want to have some bools, so some states. And let's make here some states, and let's make a private bool. And let's make first is running. And what we also want is a private bool which determines the direction in which the player is looking. So it's either looking to the right or to the left because we have to flip our player later. So let's make it is facing right. And what we can do is already set this to true because at the beginning of the game you always look to the right. So from the start it's always true, and then it can either be changed to false or not. And now to control these two bools, let's make there some code. And what I want to do is make an other, let's say void, private void, and let's call this check movement direction. And let's add here a couple of lines of codes. And the first thing I want to do is, let's say, flip the character in the right direction. And we're going to do this with an if statement. And we can always look at is facing right and the input direction, which we already called before. And what we do is if is facing right and input direction are lower than 0, then we flip. And we still have to write the action for flip. And else if, let's see, and now the exclamation mark is a negative, is facing right, and input direction is greater than 0, so meaning you're moving to the right, then we also flip again. There we go. So what this does is if you're moving to the left, so the input direction to the left is, let's say, negative, and we can put a space here. The code always ignores space anyway, but just to keep it neat, then it flips it. And if it's just it's not facing right, then it flips it to the other side. Hope that makes sense. And to control the is running boolean, we also want to add a small piece of code, which is if RB velocity x is smaller than minus 0.5 frames, or RB dot velocity dot x is bigger. Oops, sorry, this should be a minus here. Minus is bigger than 0.5 frames, then is running is true. Oops. Else is running is false. And now we just have to write the flip code, which we didn't do yet. So let's add here a flip, which is a private void flip. And the code should be is facing right, is negative is facing right, and then transform. And we do it over the rotate. We could also make the scale minus, but I like to do a rotate for this game. And let's just do 0. And then on the Y, we rotate 180 degrees. And we don't do anything for the Z angle. And then we close it here. The only thing which is now missing is to update the animator to trigger the running animation. So we already flipped the character now. Sorry, there was a small mistake there. I forgot there an F. Let's sort of check now if the movement, if let's say the character actually flips already, and it's not working. And of course it's not working because I need to also update the movement direction. So I added this check movement direction code here. And of course I need to update this every frame. So check movement direction is to be added here. And if I go now, then you can see that I flipped the character. And now the only thing which remains is to connect the animator. Go back into the code and let's add here another private void, and let's call this update animation. And to update animation, we already set our animator before, our animator a component, and there we can do set bool. This is animate bool, and we're going to set the is running by is running. And you might be thinking, huh, why you put it twice? But the animator bool is the is running. So within the animator, I also have to create this bool, which is called is running. And of course, this function we also want to update every frame. Update animation. And now let's go into Unity. Go to the animator, because we haven't set up the animator properly yet. What we want to do is add a bool here, and this is running. And the code will find now this bool is running. And let's make a transition here. Oops, not this one. Make a transition back. And here we can make the state. And what we always want to do is, especially between idle and running, is to remove the exit time. There. And let's add a condition. Is running is true. And on the way back, let's also remove the exit time. I want it to stop instantly. And here we do is running is false. And let's go game and let's not maximize because we want to see how the animator is now working based on the code. And you can see I'm now here running. And you might think, it's a little bit slow and the legs are moving very fast. So in running, I can, of course, reduce the speed. So this looks a little bit more realistic. And perhaps I can also make the characters a little bit faster. So let's go to the player. And because now the gravity is a little bit higher, perhaps let's put it to 1.5. And let's increase the movement speed to 8 or 10. We can just do this here in the inspector. Yeah, let's do 8. I think that's a good number. And let's press play. And now you have a good feeling here. Whoops, but you still kind of, let's say, launch yourself upwards, which I don't like. And that's why I like to have a, let's say, a little bit higher gravity scale. But we will also change that in the code once we start jumping. And as you can see on the slope, I'm currently sliding, or it's kind of going down if there's a slope. And we also want to fix this in a later tutorial. But for now, you can see we are running. Just play around a little bit with the speed on what you think is good for your game. And in the next tutorial, we want to add the jump function, and I'm also going to add a variable jump, so to make a small jump or a big jump depending on how strong you push the space button, and also to add the possibility to make, let's say, double jumps, which we want to unlock in later as a feature. Good, thank you very much for watching and see you all in the next video.